Okay, this is review for Chapter 6, and I think it's 6.1 through 6.4. And we already covered 1 through 5 in class to prepare you for the quiz on Tuesday, and so I will start with my other examples, beginning with problem number 6, which you did not see, but the directions were just factor x cubed plus 7x squared plus 10x, and maybe 4th hour saw this one, I'm not sure. Maybe whenever you're asked to factor, you got a few choices, but the first thing I'd always would do is check for a GCF. So you look at each term. Okay, it's in standard form, which is a great form to start with. So our highest degree is first, and then we go in decreasing order, x cubed, x squared, then x to the first. And right away I'd notice I have an x that everybody has in common, so I divide that x out, I factor it away. And so each term has decreased by 1 degree. Then I'd look at what I have left and I'd say, hold it, that's a quadratic trinomial, and we always try to break those up into 2 binomials. Remember, this 10 comes from the last term, and 2 and 5 multiplied together, those things multiply and give you a 10. And then the other spot we look at is we look at this product combined with this product, the outside and inside. And 2x and 5x add up to 7x, which is what I want in the middle. Actually, I want this 7x. The x squared is taken care of by this x out here. And so those are both positive. And so our final factorization is the x, and then the x plus 2 times x plus 5. And you could always check these things. Remember, if you FOIL those together, you get x squared plus 7x plus 10. Then if I distribute the x to everybody, I would end up right back where I started. So this indeed is the complete factorization. I know I'm done because now I've got x to the first, x to the first, x to the first. Everybody is linear, and you can't factor it past that. Problem number 7 looks like this. It says divide x to the 4th minus, that's a 4 up there, 4x cubed minus x minus 4. And you're going to divide that by x cubed minus 1. My preference is to use synthetic division whenever I can. However, because I'm dividing by a cubic, I cannot use synthetic. So I have to set up a long division problem and hope I have enough room on this screen to do it. Ooh, I'm getting ready to write down my next term. Notice it's x to the 4th, x cubed. There is no x squared, so I've got to put in a filler for that, as 0x squared is still 0. Then comes my minus x, then my minus 4. So I've made sure what I'm dividing into, my dividend, is just going in decreasing order in standard form. And then here's my divisor, x cubed minus 1. That's missing a term as well, x cubed plus no x squareds plus no x's minus 1. So I had to put in 2 zeros for that divisor. So here we go. We ask ourselves, what do I have to take x cubed times to get x to the 4th? And the answer is an x. So now I distribute that x to everybody to figure out what I'm going to subtract. And I go x times x cubed. I'm going to get plus 0x cubes plus 0x squareds minus 1 times x is x. And this is the tricky part for most people. Now you have to subtract that entire thing. So I'm doing my x to the 4th, and I go x to the 4th minus x to the 4th is 0. I go negative 4x cubed minus 0 is just negative 4x cubed. And I go 0 minus 0 is 0x squared. And negative x minus negative x is also 0, because it's going to be negative x plus x. Then I bring down the negative 4. So I've got 4 terms because that's what I'm dividing into it. To get negative 4x cubed, I have to take this x cubed times a negative 4. And I get negative 4x cubed. I get minus, doesn't matter if it's minus or plus, I'm taking it times a 0 and times another 0. Guess I should put 0 x's there so you can see what's going on. And negative 1 times negative 4 is plus 4. Draw a line, subtract. Negative 4 minus negative 4 is going to be a plus, so they cancel out. 0 minus 0 is 0, 0 minus 0 is 0. And I'm finally down to just these last two. Negative 4 minus negative 4 is negative 8. And there's nothing left up here to bring down. I've worked through all my terms, so that's my remainder. So my answer is, this is equal to x minus 4 with a remainder of negative 8. Okay. Or, more specifically, now I'd be happy with that because we're just going to write things with remainders, but it's x minus 4 plus remainder over divisor, x cubed minus 1. So that's the fractional part that it goes into it. Okay, so there was a long division problem, remembering to fill in those zeros to keep all of my terms lined up. Problem number 8. Another division problem, x cubed minus 4x squared plus 6x minus 4 divided by x minus 2. This is just a binomial with a linear binomial rather. Coefficient of x is just a 1 out in front of it. Those are set up perfectly for synthetic division then. Remember, you divide by, or you use a positive 2 in the box. Remember, always ask yourself what makes that 0, and positive 2 does. Our coefficients, let's mark all those. There's 1, negative 4, 6, and then negative 4. Okay? So it's all the coefficients. So 1, negative 4, 6, and then my constant term. Draw a line. Step 1, bring down the 1, and then multiply, and put the result up here. 2 times 1 is 2, and then we add. And then we multiply the 2 times negative 2, we get negative 4, and we add. And 2 times 2 is 4, and we add. Now remember, our final answer is not 1, negative 2, 2, 0. Final answer is, what's the answer to this division problem? I took a cubic, divided out next to the first, so I've gone down by 1 degree. I'm down to x squared minus 2x plus 2. And so there's the answer to that division problem. I'm going to quickly do that one off to the side here to show you long division and show you that it does give exactly the same answer. I've got x cubed minus 4x squared plus 6x minus 4. And so I'd go x squared, and I distribute it and get x cubed minus 2x squared. Subtract that. I get negative 4 plus 2, which is negative 2x squared, and I bring down the 6x. Next goes to negative 2x. Gives me negative 2x squared when I distribute, plus 4x. Subtract that. 6 minus 4 is 2x, and I bring down the negative 4. And I multiply by a 2 to get 2x minus 4. And I subtract, my remainder is 0. And you can see the division gives me x squared minus 2x plus 2. You don't have to check these things, obviously. We're in the point of synthetic division. Just showing you that that's what our answer comes out to be in long division as well. Question number 9 is x minus 4 a factor of 3x cubed plus 10x squared minus x minus 12. So basically that's saying, hey, does x minus 4 divide evenly into that polynomial? And I would check that by using synthetic with a 4, writing down my coefficients. Remember, there's a 1 in front of that negative x, so that negative 1 is right there. I draw my line, bring down my 3, multiply, and add. Multiply and add. And I really can't believe that's the correct answer. 3, 10, negative 1, negative 12, using 4. That's 3, 12, 22, 88, 87, some really big number, and some big number down here, minus 12. My remainder is not 0. I don't even have to know what it is because of the question. Is that a factor? Answer is no. It's not a factor. If it was a factor, my remainder would have to come out to be 0. Number 10, different type of question. 10 isn't saying is something a factor. It is saying factor this. Saying tell me how this thing breaks up as a product of stuff. Well, it's got two terms, and the first one is a cube term, so it's probably going to be a difference of two cubes. So that's a 3x that's cubed, because 3 cubed is 27, x cubed is x cubed, and 8 is a 2 cubed. So it is a difference of two things that have been cubed. And you have to remember the formula for a difference of cubes. A minus b times a squared plus ab plus b squared. And so now it's just a plug and chug problem. We go a minus b. A is the 3x in here, and b is the 2, so it's 3x minus 2. Take that a term, the 3x, and square it. 3 squared is 9, and x squared is x squared. Then a times b, 3x times 2, 6x. And finally take the 2, the b value, and square it. There's the factorization for it, and this, remember, is always prime, so you stop right here. You have to write prime, we just know it is. 11 is kind of a continuation of that problem, but it was going to be easiest in class to show you both without having to really solve or do them both. So 11 says solve this. Now if you look back at number 10, 10 is 27x cubed minus 8, and now we're trying to solve it. So now it says, hey, it equals 0, try and figure out what x has to be. This one, since we know it factors, and we just saw the factorization for it, I'm going to write it down again. Since we have it factored, all we have to do is set each factor equal to 0 and solve each of those. The one on the left, this guy, he's easy because he's linear. We love linear factors. There's one of our solutions. If you were to graph this, you would see it has a 0 where it crosses the x-axis at 2/3. That's this solution that we just found. However, this other term, or the other factor here, is prime. It's quadratic. We can't unfoil it, and the only way we can solve it is to use the quad formula on it. Remember, this is a, b, and c, so we go negative b squared minus 4 times a times c all over 2 times a. Now the stuff underneath the radical, that's your radicand. I'd be careful with that thing. Make sure you get that right. So you go on your calculator, 36 minus 4 times 9 times 9. Negative 288. I think today in class I came up with a negative 108 using my head. Dropped something there. 4ac, and there's my problem. Hold on a second. C is incorrect. If you look back here at the factorization, this last term, this last term should have been a 4. And I've put a 9 in there. I'm not sure where my head was on that. That should be a 2 squared 4. It's going to change a few things. 4ac. C is now a 4 in here. And so 36 minus 4 times 9 times 4. Yeah, negative 108. There we go. Over 18. Okay. So this, I'm going to copy this to the next page here. I'm going to take that and copy it. Because my next job is, after I figured out what that discriminant is to simplify it. Okay? So let's walk through that. I'm just going to work with this square root of negative 108. And then we'll stick it back in the problem. So I've pulled it off to the side, and I take out the I first. Okay, so now it's just square root of 108. Now I'm going to take that 108 and I'm going to start to factor it. Okay, well, it's 2 times 54. And I'm looking for perfect squares, and I don't see one yet, so that's 2 times 27. Okay, there's that 2. And then 54 factored some more. I can see now there's a 2 by 2 in there, so I could take out a 2 because the square root of 4 is 2. Well, I'll just continue to factor it. And so I'm going to get it down to all of its primes. Okay, 27 is 3's multiplied together, 3 of them. So now I'm ready to start taking stuff out of my radical. I go, oh, that's a 4. I can take the square root of that. That's 2. That's a 9. I can take the square root of that. That's a 3. So a 2 comes out and a 3 comes out. That's 6. I have my I outside and my 3 left in. So now, working back up here in the original solution that I'm trying to simplify, it's negative 6 plus or minus. I've simplified the radical part to 6I root 3 over 18. That numerator has a GCF, it's 6. And I did that because I notice 18 has a 6 in it as well, so I can do some canceling, and I get negative 6 plus or minus I root 3 over 3. Keep in mind that's 2 solutions down here. That's negative 6 plus the I root 3 over 3, and negative 6 minus the I root 3 over 3. Now, if you remember, this was a cubic equation. I should get 3 answers. My two of them are right here. Remember, that counts as 2 answers. And then I did have one at the very beginning. On this slide, x is 2/3. So that's my third solution. Okay, so that's completely solved now. I've got 3 answers that I can put down. Question number 12. Kind of a phrase a little differently than we may be used to. But it was f of x, I'll put the 12 up here, equals 4x cubed, and g of x equals 4x squared plus 3x. And the question was, find x such that, or so that, however you want to phrase it, or the x that makes it true, find x so that f of x equals g of x. So essentially what you're trying to do is solve this equation. Okay? So that's the equation we're trying to solve. And this is where in your calculators, our book gives us one choice and I suggested another one. The book suggestion is to graph this as y1, graph this as y2, and look where they intersect each other. And my method was, hey, get it equal to 0, and then look for the zeros of it. Where does it cross the x-axis? Okay? For that, you just say find 0 on your calculators. If I have time, I'll try and shoot a video for that. But right away, one of the things I'm going to notice is, hey, if you want me to solve this, I notice there's a GCF of x. And then I would try to factor this, and I'm going to try 2x and 2x. I'm going to try a 3 and a 1. There's 6, and this is 2. I want to get a negative 4x in the middle, so I want my 6x negative and this one positive. Okay? So if I were to graph this thing on my calculator, it should show me finding each of my zeros, x equals 0, 2x minus 3 equals 0, so I'm setting each factor equal to 0. That's each of these down here, set equal to 0. I should see on my calculator that it has zeros at 0, solving the second equation, 3 over 2, and the third equation, negative a half. Again, if I have time, I will try to squeeze in that section and show you on my calculator how to solve it. Problem 13. 13, we've got solve x to the 4th plus 4x squared minus 12 equals 0. This is not quadratic. but it does have what we call quadratic form to it. And for these problems, you'll find in our book that these things are always factorable, x squared and x squared, and to get 12, 2, and 6, and I'll make that positive and negative. That will FOIL out back to what we started with. 3 and 4 also give you 12, but 3 and 4 don't have a difference of 4 in the middle, so you have to use the 2 and 6 for your factorization. Now, this is factored, but it's not factored down to linear binomials, but that's all right. Once I get it factored, I can set each factor equal to 0 and then solve it any way that I know how to. In this case, I would do square rooting both sides. Square root of 2 is plus or minus root 2. X squared equals negative 6. Square root both sides. Okay, I get plus or minus square root of a negative is I root 6. So there's two answers, plus or minus I root 6 and negative I root 6, and root 2 and negative root 2. Problem 14, factor completely. Okay, factor, another factoring problem, so obviously that's going to be important on the quiz. And I probably shouldn't have had it as y equals 0, or I should have had it as 0 instead of y there. However, I was trying to give you a clue on how to get started with factoring that. Because that thing has 4 terms and it's cubic, I'm not sure how to factor it. However, you can go to your calculator and you can graph that equation. It's x cubed, and again I'll try and show this on my calculator if I've got time, 2x squared minus 5x, and I'm just typing it in now to my calculator, plus 6. And I'm going to do for that a zoom 6. Remember, that gives us the best look at it. And when I graph that, right away I see it has a 0 at negative 1. I don't know what that is. 0 at negative 2 rather, at 1, and it looks like at 3. And so if I've got my zeros, I can say it factors as x plus 2, x minus 1, and x minus 3. So there I've used my calculator to help me find the zeros. Or find the zeros, which helps me find the factors. Okay. Lastly, problem number 15, don't have one. So that's all of the problems that I have for you to review, plus the other 5 that we did in class. So study, practice the review guide that I gave you on Thursday that we went over on Friday. I'll try and get both of those things posted, this video and the solutions to that. Good luck tomorrow.